In an interesting tweet yesterday, Andrej Karpathy noted that as opposed to what most people think, which is that AI is led by data, AI is actually led by the data engine. Let's take a look. Hey y'all, it's Dr. Know-It-All. So I just want to do a quick video on this particular tweet today and explain it a little bit more and why it's so important. And of course, why it's important to realize this and not get suckered into the idea that just data by itself is the end all and be all of deep neural networks. So first, let's read the tweet. Potentially nitpicky but competitive advantage in AI goes not so much to those with data, but those with a data engine. Iterated data acquisition, retraining, evaluation, deployment, telemetry, and whoever can spin it fastest. Slide from Tesla to approximately illustrate, but the concept is general. So before I go further into this, let me first explain what data is, and specifically with Tesla, I think people are generally familiar with this, but just to recap in case you're not. So the data for Tesla would be all of the billions, I think at this point, of miles that have been driven by Tesla vehicles. Now, whether that's in full self-driving or whether a human is driving it or whatever, they're collecting all that data. And of course, that data translates into exactly what they are training on. So what's the problem with this? Well, the number one problem is the quality of data. So if you imagine, if you scrape the internet for pictures or something like that, right? So you get a lot of pictures, you're going to get, just say you want pictures of dogs. It's always dogs and cats with me. Anyway, so just say you want pictures of dogs and you want 100 million pictures of dogs. If you just randomly scrape the internet for anything that's labeled dog, number one, you might get amazing pictures of dogs. You probably will get that. You'll also get pictures of dogs that are relatively low quality. And even worse than that, you'll get pictures of like ugly people or something that someone has labeled dog or something, right? So you'll get things that are completely spurious data. So if you don't go through the process of cleaning that data and ensuring that it's actually good quality data, you're going to get garbage in, garbage out, right? That's GIGO, garbage in, garbage out. So that, of course, is the most obvious issue with data, is that you need to clean it, you need to curate it, you need to figure out what you need, how much you need, where you're going to get it, all of that kind of stuff. So it's actually rather complicated. And one of the biggest problems with most deep neural network learning things is the data. Because with the modern tools with TensorFlow, PyTorch, etc., you can actually build a neural network. I mean, you have to play with the architecture. In fact, I've been doing that all day, working on something where I'm playing with the architecture, trying to get it to work right and continue learning. But that's a relatively easy thing to do. That's something that one human being like me can just sit at a computer and tinker around with and get that to work. If you want multiple billions of miles of data, that's a whole different thing. So yes, collecting data is absolutely huge and having data is absolutely huge. But what Andrej Karpathy here is talking about is the data engine, not the data. So what's the difference between those things? The data you could imagine as kind of an artifact, right? You could imagine like a book is data. So if you take The Great Gatsby, love that book, right? That's an artifact. That's a piece of data that you have. A data engine is like having a person writing the books all the time. It's like having an author. So as opposed to something that's just sort of solidified and is a thing that just exists, it's something that's evolving all the time. So if F. Scott Fitzgerald was still alive, you could say like, hey, could you redo The Great Gatsby, but have it in a cyberpunk, 2050 world or something? I don't know. It sounds horrible. He's probably rolling over in his grave right now. But you understand the point. The difference between data and a data engine is that data is a thing that just exists. The data engine is the ability to manipulate that data, to collect new data, to manipulate the data you already have, and to produce things that you really want at that particular time. So now let's look at his tweet in particular. So first of all, the highlighted blue thing, iterated data acquisition. So that's the idea of you don't just collect data once and then you're done. That potentially could work if, I don't know, you just want historical stuff about the Battle of Waterloo or something. The data that's there is probably not going to be changing very rapidly. So you could probably collect that data once and be satisfied with the data you have. If, on the other hand, you want to train something like full self-driving or images or chat GPT or any of these things things that are kind of cutting edge, you need to not just have data, you need to have the ability to iterate that data acquisition. So you collect the data that you want, you curate it, you make sure it's good, but then you can't treat that as too precious. You need to move on and collect more data and throw away data that you don't need anymore, things like that. So you have to iterate the data acquisition process. Next, of course, we have retraining. So when you iterate on the data, right? So you collect your data, and then maybe what you do is you throw away some of that data and you add some new data. You obviously need to be able to retrain your network, and you have to do that relatively quickly. You can't spend weeks and months retraining on this data in order to be in the lead, right? You can do that if you're doing a research project and you have years to spare. But if you're trying to really develop a commercial product, you need to be able to make this happen very, very rapidly. Next up is evaluation. So as you collect the new data, you need to be able to retrain your network and then evaluate how the network is doing. So with Tesla in particular, obviously they release their sort of beta builds and the things that they've determined are quality to us driving public. But before they do that, they do millions of miles in a simulator. So they have the car pretending to drive using full self-driving hardware and all that stuff. I can't remember how big the rack is, but it's like thousands of these full self-driving hardware units. So the boards that are pretending to drive and they think they actually are driving. And so they're testing it and testing it and testing it. Then once they have it good enough for that, they evaluate it on the company employees driving it around. And then once it passes that benchmark, then it goes out to the public and then it's evaluated through the public at large. So that's the evaluation that Tesla uses. Obviously, any AI company can do something like that, but it's relatively complicated, right? This is not a simple thing to do. Evaluating the data is another critical step, and it's not simple or trivial. Finally, of course, you have deployment. So you could consider that the FSD betas that we consumers get are the deployment models. I would still say they're kind of in evaluation. So I think evaluation and deployment, at least for full self-driving, are kind of merged. Now, you could imagine that you have a product that you're like, yep, this works just as well as we need it to, and so we can deploy it. But anyway, I believe that evaluation and deployment are kind of pretzeled together. They're very much connected, which leads to the next thing, which of course is telemetry. And telemetry is just new data acquisition. So it's the ability to collect new data. So again, with a Tesla, you deploy the full self-driving, you have the cameras, you have the full self-driving hardware and all of that stuff. It drives around, and as it makes mistakes, it collects that information from telemetry, and then the mothership can request that information and say, hey, I'm looking for, people that missed stop signs while heavy rain was falling or something like that. And it can go out and flag that from the telemetry in the fleet, and then it can bring it back again. And this, of course, is what this picture from Tesla is there to illustrate. So basically, you have a data source, which is your car, right? You identify an inaccuracy, something that's wrong with the data. So again, from telemetry, you say, what is the problem? And this is all mixed up together because, of course, you have to evaluate the data in order to understand what is wrong with it and all of that kind of stuff. But anyway, you have to start someplace. It's like a giant spinning thing. But anyway, you identify something that's wrong. And then what you do is you pull out information from the fleet about that. You grab this data, I think using unit tests, you're able to do little tests internally to check to make sure things are working. But you boost the amount of data. So if something is wrong, it looks like it's a tunnel or something is not working properly in this particular image. But what you do is you collect as many of those pieces of information as you can. And if you need to, you can add some simulated information, things like that. Then you take that and you label it. And this is a critical step. So this is part of the acquisition part of the data. And I'll talk about that more in just a second, but you clean that then. So you label it, you clean it. So again, you have to curate it, throw away the stuff you don't need. Then you train on your neural network architecture. You then deploy it back to the fleet again after it's evaluated. And then the whole cycle spins up and goes around again. So I just want to draw quick attention to labeling again, and I've done videos on this, so check out the links. I'll put it at the end, and I'll also put them up in the corner right now. But anyway, labeling is a crucial thing. It started off that Tesla did their labeling by hand, as most of us do, and that was an immensely time-consuming task that human beings had to do, and human beings are not really good. They're not super fast at doing labeling. So what Tesla has been able to do over the years, and I saw this at AI Day 2022, is they've shifted most of the effort into creating auto labeling neural networks that essentially are other neural networks that have learned how to auto-label these video sequences that they get from the 8 cameras, the 8 camera 360 degree, surround view. Those things can auto-label. And that, in a way, I mean, if you think about it, the amount of data that's out there by these vehicles is quite immense. And you can get pretty much whatever you want because there are so many cars driving right now. It's the labeling and the cleaning part that is the real crux. That's the bottleneck in all of this. And so Tesla's put a huge amount of engineering effort into breaking that bottleneck and being able to do the labeling and the cleaning automatically so that humans don't have to be in the loop for the most part. And that's actually huge. That's the biggest sort of crux of all of this. Of course, the number one advantage that Tesla has is that they have vehicles that are collecting telemetry all the time, which means they have access to immense amounts of data. But the other piece of this that's just as important is the ability to automatically go out and request specific types of data, label that data, clean that data, and then present it to the neural network for retraining. And of course, obviously, you want your retraining to be as fast as possible, which is why these giant supercomputer clusters or Dojo, which is coming online. So if you think about it, who else can compete with Tesla, at least on the full self-driving front, with all of these pieces of the flywheel? They might be able to do little bits of these pieces, but they're going to run into bottlenecks, either collecting the data or labeling the data or cleaning the data or training on the data, things like that. It's going to be slower for them to do that because they don't have access to as much of the efficiencies as Tesla does in this data engine flywheel. And that's the critical advantage that Tesla has. And it's the exact reason why Tesla doesn't have to treat their data as precious. They don't collect the data once and say like, oh, don't touch this. This is our beautiful set of, 500 million images from the road. And that's what we will use forever to train on. No, what they're able to do is say like, we collected all of this data, these 500 million images, but we don't need them anymore. We're just going to go, whoosh. They're out the window. They're destroyed. The data just goes away because it costs a lot to save that much data. Then they bring in the new data that they want, which is much more about identifying specific instances where things are inaccurate, the telemetry that they've gotten, any kind of simulations that they need. They're able to then very, very rapidly automatically label it, automatically clean it, and then present it to their supercomputer clusters to train relatively quickly. That is the big advantage that Tesla has. They're able to spin this data engine much, much faster than anybody else in this space. And if you realize the amount of engineering and effort that has gone into doing all of this, from building the hardware that's in the cars to collect the telemetry, to building the cars themselves, to not just building the neural network architectures that do the inference, that do the full self-driving, but also all of the ones that do the simulations and the ones that label and clean all of the data, and even the engines that can go out and flag specific instances that they're interested in and collect that from the massive amount of data that's actually out there in the vehicles. All of this means that Tesla is basically uncatchable in the full self-driving world, which is what a lot of people say. But this is just a very specific way of seeing how big their lead is, and the reason why so many full self-driving companies, so many companies that have full self-driving arms or are working on that, have basically given up, including VW, which just today in their Audi branch has said that they're not going to bother with the full self-driving for their Artemis project with Audi. And that, I think, is a realization on their part of how difficult all this is. My prediction is that over the next 12 to 18 months or so, you're going to see one car company after another. We'll see who's willing to be the most humble first, but they will go to Tesla and they'll say, can we please license your hardware and your software? Because it's going to give us an advantage over other vehicle manufacturers who are not willing to do that. So I think people are starting to realize very quickly that full self-driving, number one, is super, super hard, as we've all said for many, many years. And everyone's a little optimistic about how fast it's going to come online. But number two, that Tesla has this data engine and they have this lead, and it's such a huge lead that nobody's going to be able to catch them. So why not just join the party and license the hardware and the software? All right, I hope you enjoyed this episode and found it fun and interesting and thought-provoking. If you did, please do like it so other people can find it. And of course, consider subscribing for more of this kind of content. As always, a huge shout out to my patrons on Patreon. Thank you all so much for your support. I truly do appreciate it. By the way, I'm going to CES in early January, I think the 4th through the 8th, if I'm remembering correctly. So if you're going to be in Las Vegas for CES, definitely come say hi to me. And of course, if you want to join the Patreon team, just check out the link in the description. And if you're interested in a whole bunch of really cool merch, check out our merch store. Link is in the description. We have TeslaBot t-shirts, the Tesla meme t-shirt, Success is a Possible Outcome, 4680 battery cells. All of that stuff is on t-shirts, mugs, tumblers, and on. So check it out. And for those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $1,600. Check out the link in the description and help the channel at the same time. Thank you. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how going shopping for a solar roof, a power wall, or anything on Amazon helps out the channel. In the meantime, I'll see you in the next one. Bye-bye.